So for question 20 from the reading, it tells you there's two different isotopes of bromine, bromine 79 and bromine 81. It's actually really cool because bromine, each isotope is about 50% of the sample. And so if you are looking at a mass spec of a compound that has bromine in it, you get this really cool pattern where basically like each peak looks like a doublet because of each isotope is two mass units apart and they're 50%. So like you have all these peaks that are the same height and about 2 AMU apart. So to solve this question, right, they tell us they want to know the exact mass of the second isotope of bromine 81. And they tell us in this problem of these two isotopes, right, bromine 79 has this weight 78.91833. And it has this abundance, about 50.69%. We're looking for this right here. We're looking for the mass of this unknown isotope. And so this is a little bit different than how we approach the problem in class, but we're given different information. So the one thing I would say is we know, right, that the abundance of both of those isotopes needs to equal 100% because there's just two isotopes, right, of bromine. So if I know one is 50.69%, the other one's got to be, 49.31%. Now, the other thing that we know is when we add the fractional abundance, when we add the weighted average from the first isotope and we add the weighted average of the second isotope together, they should equal the weight we see in the periodic table, 79.904. So I'm going to set this up like the problems we did in class, right? I've got bromine 79, I've got bromine 81, right? Bromine 79 is 78.91833. We're going to multiply that by its abundance as a decimal, so times 50.69. And then the other one, we don't know that mass yet. That's our unknown, but we know its abundance is 0.4931. And the reason why I'm doing this is because we know that the weighted average from each of those needs to equal 79.904 AMU. So I'm going to multiply bromine 79 to find its contribution. So 78.91833 times 0.5069. And I get 40.0037 AMU. So now we can find, right, the missing mass here because I know the total needs to be 79. So 79 minus 40.0037. Right. So the unknown isotope is going to have a contribution of about 39.900 AMU, right? That was what we'd get about from there. Now I can just set this up like an algebra problem, right? Basically, I have 0.4931 times x, right? That's my unknown right here. I don't know, equals 39.900. So divide both sides by 0.4931, 0.4931. And we're going to find that the mass of bromine 81 is, divide that by 0.4931. The mass of bromine 81 is approximately 80.917 AMU. So a little bit of a roundabout way, but we can use kind of the same setup we used in class to find the weight of that isotope.